Okay, today I'm going to discuss about queues. Implementing queues on second. Implementing queues using linked list. Let us see it. See, queues can be implemented in two ways. Queues can be implemented in two ways. First way is arrays. In previous class, we have discussed about arrays, right? How to implement queues in using arrays. Now, let us discuss how to represent these queues using linked list. A linked list. Implementing queues using linked list. See here, this is the array representation. Okay, this is the array representation. 10, 20, 30, 40. Index starts from 0, 1, 2, up to size -1. Here size is 4. Okay, now remember that always friend points to first element, 0th index. Always a rare points to the last inserted element. Okay, here using rare and you are going to insert the elements. Using front end you are going to delete the elements. This is the linked list, this is the array representation of the queue. Now let us see the linked list representation for the same queue. Okay, let us see it. Let us see it. See here. Here, each node consists of how many fields? Two fields. First field is a data field. Next field is next, which contains address. Next field is a pointer. Next, which contains address of next node. 10, element 10. Next, 20, 30, 40. Here, 40 is the last element, right? Here, last node, next field contains null, which represent nothing. Null means nothing. There is no next node, okay? Now, see here. See, here front must point to the front. Front, it is a pointer which contains address of first node. Here, front should always points to the first element only, right? So in the linked list also, front always points to the first node. Here, front is a pointer. Remember this. This is a pointer. Pointer which contains address of first node. Address of first node. Okay. Here, front is a pointer which contains address of first node. Next, here, what is the last inserted node? 40, right? Here, now rare points to the last inserted node. Okay, using rare end only you are going to insert. Using front end only you are going to delete. Here, front and rare are the pointers. Remember that. Front and rare are the pointers which contains address of the node. Here, front always points to the first node. Okay, that means front contains address of first node. Here, front is a pointer. Coming to the linked list, I'm talking about the linked list. Next, rare. Rare always points to the last inserted node. Here, what is the last inserted node? Node which contains element 40. Rare points to the last inserted node. Using rare end only you are going to insert. Using front end only you are going to delete. Here, front and rare are pointers which contains address of the node. Okay. And each node consists of two fields, data and next. I hope you understood, students. Now, let us see the operations. What are the operations of queue, enqueue and dequeue? Enqueue means insertion. Dequeue means deletion. Let us see it. Okay. Enqueue operation. First one is enqueue. Enqueue operation. Here, this enqueue operation is used for insertion. Insertion. Okay. This is used to insert. Let us see. I will explain. Just wait. Okay. See here. First, here, enqueue operation, that is nothing but insertion. This is similar to creation. This is similar to creation of single linked list. Single linked list. Single linked list. Okay, see here, I will say first, I will say difference between stack and top. How stack is going to create it and how queue is going to create. Let us see. First, see, this is stack. I'm explaining about stack. Just see. Linked list representation of stack. How will you create? See, first 10. Beginning of the node you will insert 20, 30. Like this. Beginning of the node you are going to insert 40. Top always points to. I'm talking about stack. Once again, students, I'll write neatly. Just wait. 10. Okay. Null. Here I'm talking about this stack. Here in stack, you are going to create in this way. First, you will create node 10, which contains element 10. Okay. Next, beginning of the node, you are going to insert another node. Beginning. Okay. 30. Like this. Like this, you are going to create 40. Like this. 10, 20, 30, 40. Like this. Okay. This is a representation of linked list representation of stack. In this way, you are going to create. Here, this stack algorithm, insertion, sorry, push. Okay, this is push operation, right? This is similar to insert at the beginning of single linked list. Okay, single linked list. Here, how you are creating? You are inserting a node at the beginning in this way, 10, 20, 30, 40. In this way, you will go. Coming to queue, see. Let us see queue. Don't get confused. Let us see queue. Okay, queue. How you are going to create? First in this way. First node you're going to create first node 10, and next here you are going here just creation. This algorithm is similar to creation of a single linked list. Single linked list. Okay, the algorithm of Enqueue. I'm explaining Enqueue operation. This is similar to creation of single linked list. Here, first node you are going to create. Next of that you are going to insert. Not at the beginning. In stack, you are going to insert at the beginning. Okay. Coming to queue, you are going to insert next of the node. Remember the difference. In stack, see, in stack, you are going to insert at the beginning. In stack, I'm talking about stack. Coming to queue, you are going to insert the node next of that node. Okay, see the difference. It's very easy. Okay, next 20. Next 30. Next 40. In this way, you are going to create. Here, front points to first node. Rear points to last inserted node. Okay, in this way, you are going to create next of the node. Next of the node. 10 node after 10, 20, after 20, 30, after 30, 40 node. In this way, you are going to create. Okay, here Enqueue operation of queue. Here Enqueue operation is similar to creation of single linked list. Let us see. I hope you understood, students. Let us see. Creation operation. How you are going to create? Let us see it. Enqueue operation. Just wait. See. 1 second. Okay, let us see it first. First step. First step. What you are going to do? You need to create a node. Okay, create a node. Using malloc function, you are going to create a node. That node name is temp. That node name is temp, which contains two fields, data field and next field. Okay, first step. Here you are going to create a node using malloc function. I'll explain algorithm later. Step 1. Create a node. That node name is temp. Okay, here node is created. Next, step 2. What you have to do? See, you need to enter the data. Okay, how to enter the data? Using the node name. What is the node name? Temp of arrow mark. Temp of data equal to 10. Tempo. See, remember, after creating a node, you need to enter the enter the value into that node in data field. Okay, in next field, null, next equal to null, next equal to null. Okay, you have entered 10, null. Name of the node is temp. Okay, once again, see step 1 and step 2. First, you need to create a node. Node name is temp. Using malloc function, you are going to create. Okay, later I will explain how to create using malloc. Okay, at the time of explanation of algorithm, I will explain. Here, first step, you are going to create a node. Node name is temp. Next, after creating node, you need to enter the value, right? So, temp of using node's name. What is the node name? Temp. Temp of arrow mark. Temp of data equal to 10. 10 will be inserted into the data field. Data field. Next field. Temp of next equal to null. Okay. Next. Next, step 3. Now, for the first time, what you need to do is, for the first time, when you are inserting first, okay, first element, when you are when you are creating first node, for the first time, what you need to do is, you need to set, see, I'm not going to explain the conditions at the time of algorithm explanation. I will say, for the first time, what you need to do is, you need to set friend equal to temp, because a friend should always points to first node only, right? What is the first node here? Node which contains element 10. Okay, that is the first node. In queue, friend always must point to the first node only. So you need, for the first time, you need to set friend equal to temp. That means you are assigning the address of temp. Here friend is a pointer. Okay, this is a pointer. Okay, which contains address. Here what you are doing, friend equal to temp means you are assigning address of temp. What is the address of temp? This one, this node 10, node which contains element 10. That address, what you are doing, you are assigning to the pointer called friend. Now friend contains address of temp. Now friend points to temp node for the first time. Step 3 will be executed for the first time when you have created a node. First node 10, null, data. Next, here node name is temp. Okay, temp points to this node. Again, friend also points to this node, because you have assigned like this, right? See this step 3, friend equal to temp. You have assigned address of temp to friend. Now friend points to same node. Which node? Temp node. Now what you have to do, let us see. Just wait. Up to here you have understood, I think. Once again, see step 1, step 2. This is the step 1. This is the step 2, entering the data. Okay, next step 3. For the first time, remember, step 3 will be executed for the first time when you have created a node. Okay, you need to set friend equal to temp, because friend always points to first node only. Now, next, completed. Next. Now, again you have to insert another node. Okay, again you need to insert another node. So again repeat the process. Step 1. Step 1, create a node. Create a node called temp. Now a temp node is created. Same steps you need to repeat. 20. Sorry. Wait. Just wait. Data field. Next field. What is the name? Temp. You have given temp, right? Using malloc. Remember, using malloc function. Malloc function. I will say at the time of algorithm how to do it. Malloc function. Using malloc function, you are going to create a node. Okay. Now, after creating node, what you need to do? Step 2. Step 2. Step 2. After creating node, you need to enter the data into that node. How to do it? Temp of, see, what is the name of the node? Temp, right? What is the field? Data field. Temp arrow mark data equal to 20. 20 is assigned to data field. Temp of next equal to null. Null is assigned to next field. Now let us see. See here. 20, null. Students, I forgot to say one thing. Please wait. See here. I'm sorry. I forgot to say one thing. See, for the first time. I'm sorry. I forgot to say one thing. See here. For the first time, this is first node. 10, you have entered 10. For the first time, what you are going to do? Friend points to, okay. See, here, after here, I forgot to say one thing. After here, what you need to do is rare also should point to node 10 only, right? Okay, so after step 3, rare equal to temp. Rare also, see, I'm sorry, I forgot to say this. Rare also points to the first node. I'm talking about the first node, node 10. I forgot this statement. See, after step 3, for the first time. Okay, once again, see, just wait. I'll draw clearly. Okay, 10, null. This is temp node. You have assigned temp address to friend. Friend points to same node, and after this step, see, for the first time I'm talking about the node 10 which contains value 10. After step 3, see what you have done. Friend points to friend equal to temp. You have assigned temp address to friend. Okay, after this what you need to do, there is rare, right? What you need to do, rare equal to temp. Temp address you have assigned to rare. Now rare points to this node only. Okay, remember. Okay, this is, I forgot this step. Last step I forgot. Rare equal to temp. Okay, now see, temp points to node 10, friend points to node 10, rare points to node 10 for the first time. Now again you need to create the another node. Which node? Another node you need to insert. Now you are creating another node. I'm talking about another node. Another node name is temp. Okay, node name is temp. Now you are entering the data. Temp of data equal to 20, temp of next equal to null. This is temp. This is temp. Okay, after that what you need to do, see, step 3. What is step 3 actually? Here, see, previously step 3 set friend equal to temp. Okay, for the first time, step 3 will be executed for the first time when you have created node containing value 10. Now you are creating another node. Okay, now what to do? Let us see it. Another node. Actually linked list is this one, right? Actual linked list. Wait, just wait one second. See, 10 node 10 node friend. This is actual linked list we have created. Rare is this. Now what to do? See, now what to do is, see here, this is a linked list, okay, which contains only one element, and now you need to insert another node 20. Now what to do means rare of, see here, rare of next equal to temp. What is temp here? What is temp? See here, what is temp? This node, right? See, temp is node which contains element 20. What you are doing here? Rare of next. What is rare? See this one. First node. Friend is pointing to first node. Rare is pointing to first node. Okay. Okay. Now rare of next means this one. This is data field. Data next. Rare next means this one. See, rare next, what you are doing? Rare next, you are assigning the address of which one? Which node? Which node address? See, which node address? Temp. You are assigning address of temp to next, rare next. Now rare next contains address of temp. Let us see. See, it contains address of temp. Now we have linked like this. This is temp node 20. This is null. Okay, I hope you understood, students. It's very easy. Okay, rare of next equal to temp. Rare next you have assigned address of temp. What is temp node? Which contains element 20. With which statement? With this statement, rare of next equal to temp. With this statement, what you have done? In the rare's next field, see, in the rare's next field, you have assigned address of temp, which here rare next field contains address of temp. That means it is pointing to temp node. Okay. After that, what you need to do, see, After this step, what you need to do is you need to set rare equal. Now you need to set a rare equal to temp, because you know that in queue always a rare must point to the last inserted node. What is the last inserted node? 20, right? Okay, you know that in queue front always must point to first node only or first element only, and rare must always point to the last inserted node. What is the last inserted node here? 20. So you need to assign address of temp to rare. Now rare points to node 20. Okay, see the diagram. Remember that a rare always must point to the last inserted element. Here last inserted element is 20. So what you must do, if rare want to point to node 20 means what you need to do, you need to assign address of temp to rare. How to do it? Rare equal to temp. You are assigning address of temp to rare. Now rare points to node which contains element 20. Okay. I hope you understood, students. Yes, this is the linked list. See here once again. This is the linked list. Now, once again, let us insert another node. Which node? Let us see it. Again, if you want to insert step 1, again create a node called temp. Create it. Its node name is temp. Okay, data field, next field. Now, after creating, what is the second step? You need to insert the elements. How to insert the elements? Temp, name of the node. What is the name of the node? Temp. Temp, arrow mark, data field name equal to 30. You have assigned element 30 to data field. Next, temp of next equal to null. What you have done? You have assigned null to the next field. Okay. Let us see it. 30 null. What is the name of the node? Temp. Temp is the name of the node. Now what you need to do? Step 3. Next step. Next step, 1 second. I will draw the linked list. This is the linked list, right? 10, 20. We have inserted this 20. 20 has null. 1 second. Data field. Next field. Data field. Next field. Always friend points to first node only. Always rare points to the last inserted element. Now, what to do? Now see here. See, rare next should contain, like this you need to insert, right? After 20, there must be 30. Okay. See, after 20, there must be 30. That means what you have to do? This is temp node, 30, null. What you need to do? You need to do like this. Like this, okay? You need to link. Rare next should contain temp node address. How to do it? Rare of next equal to temp. That means you are assigning address of temp to rare next. What is rare? See here, rare next. This is rare, right? The node which contains element 20. Okay, this is rare is pointing to node which contains element 20. Rare next means this one. This next field should contains which node address? Temp node address. What is temp node? Node which contains element 30. That node address you need to assign to rare next. So how to do it? Rare next equal to temp. You are assigning temp address to rare next. That means now rare next contains address of temp. Okay, not null. Address of temp. Next node, 30 node. That address it contains. So it points to the node which contains element 30. This is the linked list. Creation of queue using linked list. I hope you understood, students. Okay, this is the linked list. After this, what you need to do? See. Yes, see here. Rare next you have assigned temp address. 30 node address you have assigned. After that, you know that rare always must point to the last inserted element only. Now, rare should point to the node which contains element 30, right? You know that in queue, Rare always must point to the last inserted element only. So what is the last inserted element here? 13. That means now rare must point to the temp node. How to do it? See, rare equal to temp. Now you are assigning address of temp to rare. You are assigning address of temp to rare. Now rare points to temp node. Okay. Now rare points to, one second. Rare points to temp node. See, I hope you understood, students. Same steps. Once again, I will say. Once again, now you need to insert element 40. How to do it? Create a node. See, I will explain here only. One second. Okay, see here. Create a node. Create a node. What is that node? Create a node. Temp. Node name is temp. Okay. Node name is temp. Element 40. Insert element 40. How to do it? See, don't forget to write the field names. Data. Next, you need to write. Don't forget to write the field names. Okay. Temp of data equal to, how to do it? Temp of data equal to 40. Temp of next equal to null. Temp of next equal to null is very easy. If you practice, it will be easy. Otherwise, you can't remember all these algorithms. It will be very hard to you. You need to practice it, students. Okay. Yes, see here. With these statements, you have assigned values. Temp of data equal to 40. Temp of next equal to null. Now what to do? Now, here see, rare is pointing to that rare next should contain address of which node? Temp node. It should link like this, right? You need to link like this. If you want to link like this, here rare next field should contain which node address? 40 node. Where 40 node address is present? In temp. How to do it? Rare of next equal to temp. You are assigning temp address node 40 address to rare next. Rare is pointing to 30 node, right? So in that 30 node next field, in this next field, it will not contain null. Okay, previously it is null, but now you have assigned address. Okay, which node address? Temp. Rare of next. This is a rare, right? See, rare next. This one, rare next. Rare of next equal to temp. Rare of next equal to temp. In rare next field, you are assigning temp address. What is temp address? The node which contains element 40, that is the temp. That address you are assigning. That means rare next contains address of next node, temp node. Okay. Like this. Once again, see the statement. Rare next equal to temp. You are assigning temp node address. So, rare next contains address of next node. Which node? Temp node. Now what to do? You know that rare must always points to last inserted node only, right? Rare must always points to last inserted node. Here rare is pointing to 30 node. Now rare must point to 40 node. How to do it? Rare equal to temp. You are assigning temp address to rare. Now see, rare equal to temp. You are assigning temp address to rare. Now rare points to temp node. You are assigning temp address to rare equal to temp means you are assigning temp address to rare. Now rare points to which node? Temp node, not node which contains element 30. Okay. Now it points to which node? Rare. See here. 1 second. Now with this statement, what is happening? Let us see. Now rare points to temp node. Okay. Is it clear, students? See. With this statement, with which statement? Rare equal to temp. I hope you understood. Once again, see the linked list. Always friend points to first node only. Always rare points to last inserted node. Not last node, last inserted node. Is it clear, students? Students, is it clear? Did you understand? Please respond. I need your responses. Is it clear? Shall I continue? Okay, Harshita. Rajalakshmi. Okay. Only 2 students. Remaining members are sleeping, right? Remaining members are sleeping. Sleep well. Okay, sleep well. You need to respond. Harshita, okay, no need sorry. You see, if you respond, I will understand whether you are able to understand or not. So that I will continue to the next topic, right? Okay, Shravanti. Okay, okay. I hope you understood, students. Only four or five students have responded. Okay. Now let us see algorithm. I have explained according to the algorithm only. In examination, you need to write algorithm and you have to explain with an example. Just now I have explained with an example, right? Like that you need to explain step by step. Then only you can score good marks. Now see. Now see here, first step. What is the first step? Start. After that, see, allocate memory for new node. What is that node? Temp. Temp equal to how to do it? See this statement. With this statement, you are going to allocate memory for this node. See this statement. Temp equal to struct node. Here you need to write type. What is the type of the node? Struct node. Okay, type star. Struct node star malloc open bracket size of open bracket struct node close bracket, like this. Once again, see this statement. With this statement, here memory will be allocated at runtime, not at compile time. Okay, here malloc is a dynamic memory allocation method. Dynamic memory allocation method means during at the time of execution you are going to allocate memory, not at the time of compilation. Actually, for all the variables we have declared will be memory will be allocated at the compile time. Okay, for example, you have declared like int a, int b, int a of 10 array, like that. You if you have declared for these variables for array, memory will be allocated at compile time. Okay, but if you are using malloc function, here memory will be allocated at execution time. This is the difference. Okay, next, 1 second. Now see the second step. Enter data into the node named temp. You have created a node, right? What is the name of the node? Here see, temp equal to. Okay, temp equal to, right? Here node name is temp. Enter data into node temp. How to enter data? Using the field. Okay, using the name of the node and the fields. Temp arrow mark. Temp of data equal to value. Value will be assigned into data field. Next, temp of next equal to null. Null will be assigned into the temp next. Now see, for the first time, when step 3 will be executed for the first time, when you have created first node, initially, see here, initially front equal to null, rear equal to null. Okay, this is initially front is null and rear is null initially. Now, okay, see here. Now front equal to null for the first time, this condition will become true. Front is null only, right? For the first time. Okay, front null only. Null equal to null, true. When this is true, what you are going to do? Front equal to temp. That means front is pointing to the node which you have created. Front is pointing to the node which you have created. Okay, for the first time. After that, see, step 4 will not be executed. Otherwise means else part. When if condition is true, else part will not be executed. Control comes to step 5. What is step 5? Rear equal to temp. Now, front is pointing to first node. Rear is pointing to first node. Temp is pointing to first node. Okay. I hope you understood, students. Step 6, stop. First node is created. Next. 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 Just wait. First node is created, right? First node is created. Front is pointing to 10. Rear is pointing to 10. Temp is pointing to 10. Okay. Now next node you need to create. Now next node, yes, see. If you want to create next node, again you need to call enqueue operation. What is enqueue operation? Come from step 1. Temp, create a node. Its name is temp. Okay. Now its name is temp. Now next you need to enter data. How to enter data? Temp of data equal to 20. Temp of next equal to null. Now see here, step 3 will not be executed because friend contains some other address. Okay, it does not contain null, it contains some address. Okay, some address equal to null, this is false. Okay, this condition will not be executed. Control comes to otherwise part. What is otherwise part? Rear of next equal to rear of next. See here, step 3 will be executed only for the first time when you have created node 10. At that time, friend will be null. Now, friend is not null. Friend contains address of first node. Okay, it is not null. So, step 3 will not be executed. Control comes to step 4. What is step 4? Else part. What is else part? Rear of next equal to temp. See, like this you are linking. Rear next equal to temp. Like this you are linking. Next, what is fifth step? Rear equal to temp. You are making rear to point to temp. Okay, see the diagram. Now, like this, you are going to do it. Now, see the diagram, students. Please see the diagram. Now, rear points to node 20. Okay, in this way, it is going to. If you want to insert another node 30 again from step 1. Okay, it's very easy. If you follow the algorithm, you need to trace out or you need to practice it. Like this only, like this. See, I have drawn the diagram, right? Like this only you have to practice. At that time you'll get it. No need to remember all these things. If you remember, you'll get confusion. Okay, if you practice only, you can write without seeing. It's very easy. Practice at least 2 times. Now, yes, deletion. Let us see deletion operation. Deletion, let us see it. Deletion means DQ operation. DQ is nothing but deleting. Okay, deleting node from the linked list. Here, this algorithm is similar to delete a node at the beginning of single linked list. Okay, remember that. Here, DQ operation. What is DQ operation? DQ means deleting a node from the queue. Sorry, yes, from the queue linked list. Here, this algorithm is similar to deleting a node at the beginning of the single linked list. You know that in queue, first inserted element. See, what is the principle of queue? FIFO, right? FIFO. FIFO means first in, first out. First in, first out. FIFO. First means first one. In means inserted. First inserted. First out means first it will be deleted. First inserted element will be deleted first. Now, if you want to delete a node in queue, how to do it? First node only you can delete, right? Because first inserted element will be deleted first in queue. So, if you want to delete a node, you can delete only first node. So, the algorithm of DQ is similar to the deleting a node at the beginning of the single linked list. Both are same. Now, let us see. Now let us see. See here, this is the node. Sorry, this is the linked list. 10. Like this you are going to create. After 10 next, node 20. After node 20, node 30. Like that. Okay. 20. 30. Null. Rear always points to the last inserted node. Front always points to the first inserted node. Front contains here, remember, front and rear are pointers. Star front, comma, star rear. Okay. Pointers which contains address of the node. Now see here. Now what to do? First, what you need to do? Deleting means only in queue first inserted element only will be deleted. What is the first inserted element? Element 10 is the first inserted element. So this you need to delete. See, if you delete this, Friend must point to the next node, right? Because you have deleted node 10. Friend should point to the node 20. This is the algorithm. Sorry, this is the how deletion operation. After deletion operation, like this it should be. Okay. See, if you delete node 10, if you delete node 10, friend must point. Friend actually in array you are going to increment friend, right? In arrays, what you are going to do, you need to increment friend. That means friend must point to the next element, because first element you have deleted, right? Now coming to the linker list, here you are deleting node 10. If you delete node 10, friend must point to the next node only, right? Because first node is not there, right? So after deletion operation, linker list will be like this. Friend will point to 20 and rear points to the last inserted element. Okay. Now let us see step by step how to delete it. Let us see step by step. One second. Don't forget to write field names. You need to write field names. Data next. Data next. Friend points to first node. Now, now you need to take, see, you need to take a temp. Temp is a pointer only, okay? Temp equal to assign address of friend. Okay, assign address of friend. Here temp equal to friend means you are assigning address of friend to temp. Now temp points to first node, okay? See here, you have assigned address of friend, right? See, step by step, I'm explaining step by step. First, what you need to do? You need to take a pointer. Okay, you need to take a pointer. What is that name? Temp. Actually, in declaration, you need to give like star temp. Okay. In declaration, you are going to give like this. Temp equal to friend. You are assigning address of friend to temp. That means now temp points to first node. Okay. After that, what you need to do? See, after that, you need to make friend to point to the node 20. You should make friend to point to the node 20. Now, where is the node 20 address? See here. Friend, see, friend is pointing to node 10. Okay, node which contains element 10. Now, what you need to make after this statement, after making temp to point to friend, see, temp equal to friend, temp is pointing to friend. You have assigned address of friend to temp. Temp is pointing to friend, okay, friend node. Now, after this statement, you need to make a friend to point to you need to make friend to point to the node 20. Okay, so where the address of node 20 is there? In first node next field. First node next field contains address of next node. What is that node? Which contains element 20. So friend equal to, what you need to do? Friend equal to front equal to front of next. What is front of next? This one, see here. Front equal to front of next. This one. This contains address of which node? Node 20 you are assigning. See, front next. This one. Front next. Once again, see. See, front next. Front next contains address of node 20. You are assigning that address to, once again, to front only you are assigning. Okay. That address, which node which contains element 20, that address you are assigning to, once again you are assigning to front. Now front points to node 20. Okay. Node 20. Front points to node 20. I hope you understood, students. Once again, see. What is the first step? Temp equal to friend. Temp points to friend node. Next, what you need to do? You need to make friend to point to the next node. So you need to make like this. Front equal to front of next. Front of next means next node address. 20 node address you are assigning to front. Now front points to node 20. Okay. After that, what you need to do? See, you need to delete. You need to delete temp. Temp is pointing to first node. What is that first node? Node which contains element 10. That node you need to delete. How to delete it? Using free. Using free. Free function. Free of temp. Temp will be deallocated. Temp memory will be deallocated. See, free of temp means memory will be deallocated. Now this is the linked list. Memory will be deallocated for the temp. Now this is the linked list. I hope you understood, students. Okay. Is it clear? Is it clear? I'm explaining according to the algorithm only. One by one, step by step, I'm explaining. Is it clear, students? Is it clear? Rajalakshmi, okay. Remaining members. Teja, Kavya, Harshita, Neelaveni, Shravanti, Mahita. Roll number 17, okay. Teja, okay. Okay, students. See, you need to practice, okay. You can't remember. See, once again, I'm saying you can't remember algorithms. There are many algorithms. If you by heart, you can't present it in your examination. If you practice and understand with an example, practice with an example. Take an example and practice step by step. Just now I explained, right, step by step. Like that, you need to practice. At that time only you can understand. So at least in examination, you can attempt it somewhat correctly. If you practice well, you can attempt correctly. Okay, do it, practice it. Now, algorithm. See, in examination, first you need to write definition. After writing definition, you need to write algorithm. After writing algorithm, you need to explain like this. See here. See, with an example, I took with an example like this, you need to explain. Inserting another node, for inserting first node, inserting another node like this. Like this, you need to do it, okay? Now, I will explain. See, this is the DQ example. Like this, you need to explain neatly. Now, let us see the algorithm. First step. 1 second. First, what you need to do? Ten, 20, 30. Rear always points to last inserted element. Front always points to first inserted element. Data field, next field. Okay, let us see it. Now, first step. What is first step? Friend temp equal to friend. Okay. See, temp equal to friend. You are assigning friend address to temp. Now, temp points to which node? First node. Temp points to, see the diagram. Temp points to first node. Now, next, what you are doing? If friend equal, see, if you want to see first statement. 1 second. Coming to, okay. See, if you want to delete a node, here there is no overflow. Okay, students, remember, here there is no overflow. You can create a long list of chain. Okay, you can create it. There is no overflow. There is no size. Just like arrays, there is no overflow. But coming to DQ, deleting, if you want to delete, there must be linked list, right? Here, remember, in Enqueue, here in creating linked list, there is no overflow. You can create any length. It can be of any length. You can keep on creating also. Okay, there is no overflow. But coming to DQ, deleting the node. Here, if there is no linked list, how can you delete the how can you delete the node if there is no linked list? You cannot delete the node, right? So here you need to check whether there is underflow condition. Underflow means there is no linked list. If there is no linked list, if you are trying to delete a node, here underflow condition will be displayed. See, if front equal to null, when front is null, when there is no linked list. Initially front equal to null, rear equal to null, right? When front equal to null and rear equal to null, there is no linked list. Okay, so when rare and when front is equal to null, if this condition is true, control comes inside the if statement. If a body, what is there? Right means print underflow. Underflow will be underflow will be printed onto the screen, and exit means stop the algorithm. Okay. Here, no, there is a linked list. If there is a linked list, front is not null, right? Front contains address of first node. So, front is not null. Front contains some address. So, step 3 will not be executed. Control comes to next statement. What is the next statement? Set front equal to front of next. Front equal to front of next. Front of next means next node address that you are assigning to front. Now, front points to the node 20. Front points to node 20. See the diagram. Front points to node 20. Okay. Now see, after executing this statement, come to step 5. What is step 5? If front equal to null, you need to make rear equal to null. Okay. If front is null means there is no linked list. If there is no linked list means you need to make a rear to null. Okay. Remember this. If front null means what you need to do, you need to make a rear also to null. Front null means there are no elements to delete. There are no elements. If there are no elements, you need to make a rear also to null. Remember that. Next, after this, deallocate memory for temp. What is temp? Temp is pointing to which node? First node. You need to deallocate memory for that node. How to do it? Free. See here. Free of temp. Free of temp. Here, temp node is deallocating memory. For the temp node is deallocating. To deallocate the memory, you need to use free. To allocate memory, you need to use malloc. To deallocate, delete. To deallocate memory, you need to use a free function. Free of temp. Free of temp means what is happening? This node you are deallocating. Okay. See the diagram. After fifth step, what is the sixth step? Stop. Here you need to remember the conditions. And stepwise, what is happening stepwise? I hope you understood, students. This is the DQ. This is the Enqueue operation and DQ operation of queue using linked list. It's very easy if you practice. I hope you understood. Any doubts, students? So, with this, your third unit is completed. With this, your third unit is completed. I request all the students to download the PPT. I didn't prepare the notes. Same, whatever the content is present in the PPT will be in notes only. Notes also. I didn't prepare the notes. So, I request all the students to download it. Same content in notes also. Same content which is present in PPT will be there. Okay, so I didn't prepare notes. So I request all the students to download the PPT, third unit PPT, and practice all the questions, all the algorithms and with examples. And also types of queue. Types of queues, I have uploaded types of queues notes. I have written that notes, types of queues that notes also download it. And please refer it. Your third unit is completed. Next class, I will start fourth unit. Your fourth unit is trees. Let us see. 1 second. I will open it. Please don't leave. After 4 o'clock, you can leave. Now don't leave. I will open. Just wait. Okay, see here. Stacks and queues. First unit, see second, third unit. See, third unit is completed. You need to practice. First, I had discussed about stacks first. Later, I had discussed about queues. Okay, first is queue and next is stack. So, unit is completed. Next, fourth unit. In next class, I will discuss trees. Okay, trees. See here. Syllabus is basic terminology of trees, binary tree, BST, and how many topics? 1, 2, 3, 4, 5. 5 topics are there. See students, I will explain only with an one example. Later you need to practice it from trees. Okay, here from trees, from the next class I will start unit 4. In trees I will explain only one example only. You need to practice the examples and algorithms also. If you are not writing algorithms means you will lose marks. Remember that. You need to practice algorithms. Don't by heart it. Practice at least twice with seeing, and you need to write without seeing also. At that time you can understand whether you are able to write or not. Don't leave the class. Up to 4 o'clock you should be. Okay. Now see here. Unit 4. Unit Unit 4. Unit 4 is trees. See, what are trees? Tree is an example for, once again, see, there are two types of, one second. See, there are two types of data structures. Two types of data structures. I'm not explaining unit 4. Just see here. There are two types of data. There are two types of, one second, data structures. Linear data structure and non-linear data structure. Here, what are the examples of linear data structure? See here, stacks, queues, array, and linked list. These are the examples of linear data structure. See, these are the basic questions. You need to know it. See, there are two types of data structures. First one is a linear data structure. Examples of linear data structures are stacks, queues, arrays, and linked list. Okay. Coming to non-linear data structure, examples of non-linear data structure are trees. Remember this, trees, graphs. Okay. These are the two types of data structures. Linear data structures are stack, queues, arrays, linked list. Coming to non-linear means non-linear data structure means data are not arranged in some sequential order. No, data are not arranged in sequential order. They are arranged some randomly, not in a sequential order. Data will not be present in sequential order. It will be in some random order. Okay. That's why they are called non-linear data structure. Examples of non-linear data structures are trees and graphs. Now let us see definition of trees. See, there is time. Please wait. Please wait for 2 minutes. Next class, I will start unit 4. Unit 3 is completed. Let us treat just a tree definition. That's all. I'm not going to explain anything. Just a tree definition. What is tree? It is a non-linear data structure. Non-linear data structure which contains, see, which contains, just a definition. See the definition only. I'm not explaining anything. It is a non-linear data structure which contains a root node and child nodes. Only nodes. It contains a root node and child nodes. Let us see. This is a root node. A, B, C. See, this is a tree. D, E, F. See, this is a tree. Okay. Tree will be in this way. See here. What is root node? Superior node. This is called root node. And all other nodes are called child nodes. In detail I will explain in next class. See how tree is represented. Tree is very easy. See the definition. It is a non-linear data structure which contains a root node and child nodes. Like this, diagrammatic representation is this, root node and child nodes. This is the tree. Okay. In the next class I will discuss. Okay, it's 4 o'clock. Okay, you can leave, students. I hope you understood what is tree. In detail I will explain the next class. Okay. Now you can leave. Thank you, students. Any doubts, students, please respond if there are any doubts. Once again, I will explain. I will take time and explain. If there are any doubts, no doubts, no one will respond. Okay, Sohel. Okay, please.